Remember, everybody, we talked about how water is polar in nature. It has covalent bonds between the oxygen and the hydrogens, and because of this, it gives water a couple of special properties. Two of them are adhesion and cohesion. And we're going to demonstrate those by looking at how many drops of water we can put on a head side of a penny and a tail side of a penny. So we'll start out with the head side. 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Notice the bubble that's forming. 31, 32. Oh, 33 we got out of that one. 18, 19, 20, 21, 22, 23, 24, 25. Oh, 25 on this side.
So take a moment into your lab and record quantitative data and qualitative data. So sketch what you saw when you were doing the penny and water, and identify how many drops for each side, and then you need to answer questions 1 through 3 about cohesion and adhesion.
All right, go.
Okay, so the next part of the lab is looking at how water can be the universal solvent, meaning that it is polar, so a lot of different types of molecules are able to dissolve in a water liquid. So what we're going to do is demonstrate that through using Kool-Aid and water. So we're going to take a little bit of Kool-Aid, 1 tablespoon. We're going to mix it in water and see what happens. And as you zoom in and you look closely, you'll notice that the Kool-Aid powdered mixture is dissolving and completely forming something called a solution, where the solute, which would be the Kool-Aid, is dissolving completely in the solvent, which would be the water.
At this point, notice at the bottom of your lab, under observations, that we're looking for some qualitative analysis, some qualitative data. So record what you see, what you started with, what you ended with, right here at the bottom. And then, flipping your paper over, there are some questions that go along with how polarity plays into dissolving, how it plays into the creation of solutions. Answer those before moving on to the last section of the lab, the pH of water. Hopefully by this point you've recognized that we've been talking about the same characteristic of water, and that is the fact that it is a polar covalent molecule, polar covalently bonded molecule, and because of that it has several different properties that go along with it. And one of those properties that can be measured a little more quantitatively is pH. So what we have here, we're going to test the pH of just standard water, baking soda in water, and cola, some Coke here. So we'll start with the water, and we dip our pH strip into the water, we pull it out, and if we set it here next to our indicator, it tells us that, as we would probably expect, the pH of standard water right out of the tap is 7, right? Neutral. If we move over to baking soda and water, maybe you should make a prediction in your head here, see what you think it might be. Let's check it out. If we set that over here, you can see we're moving up the pH scale a little more towards the basic end of the scale here, so we're probably at 9 or a 10, it would look like, in comparison and contrast rather to the pH of 7. And then finally the Coke. If we put that on the scale, we can see that we're more at a 4 or a 5, probably close to a 4 there. So pH, again, affected by the type of solute that you put into water, but standard water itself, neutral.
Okay, so going back to your lab, the pH lab part C, you would want to collect both quantitative, so you'd record the pH level, the qualitative data, so the colors in which you're seeing with the different pH levels, and then finally there are 3 questions to answer regarding pH.